Okay, so the next topic here in section 8.3 is called Cramer's rule. It's a formula, or a trick really, to solving systems of equations using determinants. I'm not going to go through and derive how this rule works. You're going to have to trust me that it does. The derivation for this is in your textbook or ebook on page 575 towards the top. And so they derive how this comes out. Basically, to derive the formula, you just use the most general system with like ax plus by equals c and so forth, using just letters in there, and then you use the elimination method, which looks a little bit complicated without numbers, and you come up with this formula. Okay, so the idea is this. In this system, we looked at the augmented matrix in section 8.2. But if you look at this, there's actually different ways to combine this so that you can get 2 by 2 matrices. For instance, one really nice matrix is the one that just takes the coefficients. Okay, so if you just look at the 4 coefficients, you have the matrix 1, 3, 2, -3. And if I find the determinant for that matrix, I would have, let's do this, I would have a -3 going down, I would have 6 going up. Remember, then we change the sign on the top term and then add them up. So this would end up being -3 minus 6 is -9. Okay. So that's one of the possible 2 by 2 matrices that occurs here. Another matrix that's going to be very important is one where you replace the x column with the constants. And so the first column becomes 5, -8. The second column stays 3 and -3. Again, we do the determinant, so we multiply the diagonal down. Get a -15 here. Diagonal up, we get a -24. Don't forget, on the top one, you must change your sign, and then add them up. So -15 plus 24 is equal to a +9. The other matrix that's going to be interesting is, instead of replacing the x's with the constants, we replace the y's with the constants. And so your matrix ends up looking like 1, 2 going down, and 5, -8 for the second column. Again, we're going to do our diagonals down, so that would be a -8. This here is a 10. And again, don't forget to change your sign on the top. When we add these up, we get -8 minus 10, and that gives us a -18. Now, what's interesting about these 3 matrices is that their ratios give us the answer. Remember, this matrix we've seen the solution for a couple different times already. I'm sorry, this system we've seen the solution for a couple different times already. And so I put the solution here just aside so we could see it kind of pop out. Now, what's nice about this is if we have names for each of these 3 matrices. The first one was the matrix D. It's just all of the 4 coefficients. The second one we call D sub x. It's where we replace the x coefficients with the constants. And the third one, you probably guessed it, is d sub y. It's where we replace the y column with the the constants. Okay. Now, what's interesting is that Cramer's rule will tell us that the final answer can be calculated by taking combinations of these matrices. In fact, the x value is found by taking d sub x and dividing it by d. Okay. Notice that d sub x is 9, d is negative 9, and when you divide them you get negative 1, which is the x value of our solution. In a similar way, the y value can be found by taking d sub y over d, which would be negative 18 over negative 9, and that ratio is 2, which is also the y value of the solution. And so this pattern will continue for every system of two equations that you'll find. In fact, if you think of this in the most general form with a system, let's call it ax plus by equals s, I believe is what the book uses, and cx plus dy equals t. And if we define our three determinants as d equals the determinant a, b, c, d, d sub x is st, it replaces the x column with the constants, and bd stays, and d sub y is equal to acst, so the y column gets replaced with the constants. Then the x value is always going to be d sub x over d, and y will always be d sub y over d. Okay, so that combination will always be true using a system of two equations. So you find the three determinants, just like I did in the previous example, and then divide those answers in this way, and you will always get the correct solution to the original system. It's kind of a cool trick, and it is especially neat when we do the three equation systems in the next video.